Hello. So in this final video for this worksheet, what we want to do is formalize what we've been looking at into a couple basic rules. So the graph of y equals x squared minus 5 is the graph of y equals x squared translated. So let's take a look up here. So y equals x squared is the green. Y equals x squared minus 5 is the gray. So we see it's been translated down 5 units. Down by 5 units. The graph of y equals 1/2 x squared minus 1 is the graph of y equals x squared stretched. And so we remember from our previous worksheet that if the a value in front corresponds to a vertical stretch from the x-axis by a factor of 1/2, so that means it's actually crushing it, making it, moving it closer to the x-axis, and then translated down by 1 unit. So what you might have noticed now is that both of these have a minus k value. So that means that if it's minus, it's going down. The graph of y equals x squared plus k, where k is greater than 0, is the graph of y equals x squared translated up by k units. So if we take a look back here again, let's look at y equals x squared plus 2. So y equals x squared is the parent graph. That is the graph we start with, and that's in green here. When we say y equals x squared plus 2, we take that same shape and we move it up 2 units. So now we want to complete this, and we've actually already done this, but one of the statements I made in my last video was, how can we do this without graphing it? Well, what do we know here? We know that what's happening in this graph is it's being shifted. So we say shifted or translated down 5 units. Right? Because we see that it's minus, so it's down 5 units. So again, we're not moving it left or right, we're just moving it up or down. So that means if the vertex from my parent graph, so if the vertex for y equals x squared is 0, 0, if we shift this down by 5, if it is shifted down 5, the vertex is 0, minus 5. So what do we see here? We see that the vertex, so if y equals ax squared plus k, the vertex is 0, whatever the k value happens to be. So let's come up here. Vertex 0, and the k value here is minus 5, minus 5. Again, the axis of symmetry. We haven't shifted this left or right. We've been shifting it up and down. We've been stretching it vertically. So nothing has changed to the left and right position, so the axis of symmetry doesn't change. So the axis of symmetry remains, x equals 0. Remember, you have to give the equation of a line. If we look at this, the a value is 1, so the direction of opening is up. Now we haven't actually written in the a value, but if there's nothing written there, it means that there's an implied 1. And since this opens up, we will have a minimum, and the minimum value is going to be at, if we take a look at our vertex, it's minus 5. So the minimum value occurs at minus 5. So again, this sheet, the purpose of it is to kind of take us through the process here of, we start by looking at completing a table of values, And then we eventually want to link that into, well, what do the graphs look like? And again, what we're trying to do is come up with a set of rules that allow us to apply transformations to a parent graph. And the parent graph here is y equals x squared. So we see if we add or subtract a value after we take the square of the x value, it's shifting it up or down. And we summarize the concept here in this last table. I hope that helped.